Okay, so the last one that we're going to be working on is number 4. And there's a few things in number 4 that I think are really important for us to look at as far as notation goes, here and here, and being able to set up 3 functions in a piecewise, and be able to tell whether it's a function and answer the questions. So the first thing we're going to do is we're going to take a look and notice that our first one is a quadratic. It's got that parent function x squared. So we are going to start with that one. So we're going to write x squared minus 1 down. And our x values that go with this, we are going to begin at 0. And they want values that are less than or equal to 0. So less than 0 is -1, -2, -3, -4. And we're going to plug these values in and see what values we get for y. Once you get to values for y that are too big to plot, then you just stop. Okay, so 0 squared minus 1 is -1. -1 squared is +1, minus 1 is 0. -2 squared is 4, and 4 minus 1 is 3. -3 squared is 9, 9 minus 1 is 8, and -4 squared is 16, minus 1 is 15. So I know that this last one isn't going to work. It's not going to happen. So I'm going to start here, and this isn't equal to. So this one is going to be closed. It is closed because it has an equal to. Okay, so at 0, -1, close circle, -1, 0, -2, 3, -3, 8. Oh, that's right at the top. 1, 2, 3, 4, 5, 6, 7, 8. And that's all we can do. And this is our parabola quadratic, just like that. That's our first piece. Our next piece, we're going to transition, and we're going to do 2x minus 1, and that's linear. Our parent function is y equals x. This is an mx plus b form. And for our xy table, the first value that we're starting with is 0. And we are moving to 5. So we are doing 0, 1, 2, 3, 4, 5. Those are the x values that we are using. And if you notice, on the 0 side, this is going to be an open circle. It's open because no equals. And this one is going to be a closed circle. And it's closed circle because there is an equals. Okay, so we're going to fill in these values for our middle guy right here. Starts at 0, ends at 5. 2 times 0 minus 1 is -1. 2 times 1 is 1, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. That's 6 minus 1 is 5. That's 8 minus 1 is 7. 10 minus 1 is 9. So this one's not going to fit too tough, but we'll make it happen. So we're starting at 0, -1. It's already filled in, but I'm putting my circle around it. Then 1, 1. 2, 3. 3, 5. 4, 7. And 5, 9. And 5, 9 kind of bumps off the grid, but it is closed. And this does not have any arrows on it. It doesn't have arrows because it's a start and a stop. So which means it looks more like a barbell. And then we've got our last one. And our last one is 3. Literally just says 3. So this is y equals 3. Y equals 3 is a constant horizontal line. And they want values where x is larger than 5. So when we set up our table, we have to put 5 down, but 5 is going to be open. Okay. And then we want larger than 5. So 6, 7, 8, 9. And since y is 3, we're literally just filling y with 3. That's what this means. Horizontal line where y is 3, all the y values are 3. Okay, and so we're going to plot this one. We're going to start at 5. 1, 2, 3, 4, 5. We're going to go up to 3, and this is an open circle. Open because this says greater than. Then we need 6, 3, 7, 3. It's going to go this way. Okay. So this is literally what our piecewise looks like. We've got a quadratic going into a linear with a slope of 2 and then drops to another linear with a constant zero slope right there. Now we can answer some questions. First of all, is it a function? Does it pass the vertical line test? Does every 1x have a y value? Yes. Even this one, because this is a closed and this is an open, that means only one y happens to that x value. So yes, this is a function, passes the vertical line test. Now we got to take a look at -2. So -2, what category does that fall under? Well, -2 is less than 0. So I'm going to put -2 in here. So -2 squared minus 1, that's going to give me 4 minus 1, that's 3. 0. Well, there's zeros here and here, but we want the 0 with the equal to. We want the 0 with the equal to, so we want this one. So we also want 0 squared minus 1, which is -1. And then the last one is 5. Which 5 do we want? We want the 5 with the equal to. So that means we want this one, the 2x minus 1. Okay. So that's how you do piecewise. That's how you graph them. That's how you tell if it's a function. You look for vertical line test. And this is how you use the domain of values to answer questions about those functions.